or networking essentials. So I put a name basics, but it is networking essentials. Means the major part of networking we are going to discuss here. Means main basic part we are going to discuss. Routing, switching, that kind of CCNA, we are not doing that one right now. Okay, that is not there in your syllabus. The basic, what is the network? So what we are going to see in this networking, and what is the advantage, like why we are learning this. Of course, it's one point is your interview, and of course, while you are working in your profile, networking related work is also important. Okay, network configurations and related to troubleshooting also important. Updations, upgradations, remote connectivities, all these things are very important while for working. In the future, you want to learn anything, like you want to learn a cloud, or you want to learn anything related to the Windows administration, Linux administration, network administration, okay, security related. If you want to learn anything, this topic is very helpful. This is the fundamental basic topic. Some of you from CSC or ECE background people may have certain part of networking basics, right? So computer networks is there. It is also similar, but approach is little different. Okay, the way of approach is a little different from your what are you studied in the academics. Okay, and what we discuss here, what is meant by why we need a network, what is meant by communication, what are the different types of communications, what is network, networking, internetworking. Okay, what are the different physical topologies, what are the different types of network like LAN, MAN, CAN, WAN, what is intranet, internet, how we are connected to internet in your home, or how we are connecting to internet. Okay, what are the different devices, different things required. The basic requirements to form a network and communicating in the network is like what is NIC, what is the different cables we use in the network, what are the networking devices we use it, what is meant by IP addresses and protocols. After that, again, we're going to see about a OSI model, TCP IP model, how to use OSI for troubleshooting networking related issue, networking related commands, basic networking troubleshooting things, okay, Wi-Fi related configurations also. And this is one of the major topic after a service desk. Okay, this is also one of the major topic and lengthy topic also, guys. Okay, it won't be finished in that much easy. Okay, it will take at least 3 to 4 days of topic. It is. We'll try max to max how much fast we can able to connect. So one day we'll dedicate for troubleshooting commands and kind of stuff. But remaining things we will going to see. Very small practicals are there. That is also you can try. So which one you can try in your system? That compulsory you have to do it. Like checking of IP addresses. Okay, like that. Checking like okay. Yeah. Some people are joined. So who are there? Dharani, Harika joined. Subramaniam also joined. Very good. So now you got 10. Okay, we'll start here. Why we need a network? Simple to say, some as regular people say, to communicate between the devices, we need a network. To communicate between the devices, we need a network. What is meant by communication? So what is the first point? Why we need a network? What is the use of network? Okay. So what is it is? The first one is to communicate between the devices. And it's the second one. What is second one? What is meant by communication? Sharing of information, data, or resources. What is communication? sharing of information, data, or resources is a meant by communication. Next, what are the different types of communication? Third point. What is the different types of communications? What we do in communication daily with our internet, we're accessing different websites, right? We're accessing different websites, google.com, facebook.com, youtube.com, right? w3schools.com, tpointtech.com, tutorials.com, microsoft.com, right? Different websites we are accessing, right? Different web related communication. So one type of communication. We are sending mails, receiving mails, mail communications. We are uploading files and download. File transfer related communications. Okay. So different types of communication we can add. So commonly we understand this website we are accessing, web communication, web-based communication. Instant messaging. Messaging. You send a messages, right? Message related communication. WhatsApp messaging, simple. Okay. So a lot of other instant messaging applications also, like earlier we have a Google Talks. Before that one we have Yahoo chat boxes. Now we have WhatsApp, right? Different types of communication, different type of identity, different way of communication. Instant messaging communications, web communication, mail communication, remote file transfer related communication, remote device accessing communication. Entire device we can able to access remotely. We are able to access that one. Remote access, like a remote desktop. Okay, this is some other computer I'm accessing from my system. This is some other computer. That computer I'm accessing from my system. It is remote desktop communication. Similarly, you can use different protocol as such as Telnet for remote device access communication, remote device communication, remote device accessing communication, remote access communications. Authentication communication, like so a lot of different communications are there. Okay. As I said, what is meant by communication? Sharing of information, data, and resources, right? Sharing of information, like you're sending a mail or you're accessing information through web. Okay, these are all sharing of information, sending a message, information, sharing your data is information. Okay, resources. Here I accessing entire computer. Okay, that is entire system I'm accessing resources. Sharing of data. This some computer having a data. So my remote system having some data. I'm accessing that data from my computer. I'm accessing that computer entire system from my computer. Like that. I can control, I can use that system. So these are the about a communication and network. How it is all possible? Because of network. Without a network, you can't connect it to another system. You can't access that system and resources or information like that. So my remote computer also having a printer connectivity. I want to take a printout from that printer. The printer is not connected to my system. Printer is connected to another system. Our printer is connected to a network. I want to take a printout. So accessing resources. Okay. So this is the first initial point of your network. Why we need a network? To share information, data, resources between the devices, we need a network. Or to communicate between the devices, we need a network. What is meant by communication? Again, sharing of information, data, and resources. What are the different types of communications? Web communication, mail communication, file transfer related communications, remote access related communication, remote authentication related communications. Okay, like a different types of communications are there. Understand, guys, the first point? because I didn't write in any 3-4 lines for that one. Just I given one line and I'm telling the lines. That's it. Got it? Why we need a network? What is meant by communication? Types of communications.
Yes, sir.
Right. Next. Then what is network? Simply, what is a network? Interconnection of two or more devices. So with one single device, you can't create a network. So you need a two or more than two devices. Two or more devices. Two or more devices are required. You connect two or more devices, that is simply a network. Interconnection of two or more devices or connection of two or more devices is a network. Then what is meant by networking? What is meant by networking? Why I put a three devices? Because if I put a two, people fix the two devices only. So it is not a one, two. It can be one, it can be two devices, it can be three devices, it can be 100 devices also. If you connect the devices, you created a network. Simple. And the network word we use in different places, different way, guys. But network is a common thing only, but different ways. Logical network, physical network, like that. Lot of places we use the network in different way. Okay. Yeah. So this is I created a network. Okay. Now, what is networking? Networking. So network is connectivity. Networking means communication. You communicate between the devices. A send a packet to B. So communication. So if you connect, you create a network. In the network, you communicate between the devices. You share the data, resources, or information. This is your net. So like this, you have a multiple networks. In case you have a multiple networks. Yes, you have a multiple networks are there. For example, this is network 1, network 2, network 3, network 4, network 5. Like you have a different networks. So their devices will communicate each other. Means A1 is communicating to B1, A1 communicating to C1. Same thing like this. A2 can able to communicate it to B2 and C2. This is one network. This is another network. So in the world, so there is a lot of networks are like this. In your home, your Wi-Fi router, your devices, one network. In our office, my laptop, other laptops, other desktops, other servers. It's a one network only. Like a so lot of networks are there in this one. But how you make them communicate each other? Okay, how you make them communicate. So there is a backend internet public. So I'm not going through that one. Simple one term purpose. I'm telling that. What is it? Simple. You have a different networks. Physically, logically, separate networks. Now you want to make them communicate each other. You want to make them communicate each other. So you have to connect these networks using internetworking devices. The devices want to communicate. Sorry, these networks I want to connect. So then they will able to communicate each other. Okay. So different ways it is connected. Different networks are connected different ways. So it's not like that only one-to-one only communicate connectivity or one-to-many connections are there, whatever it is. The networks are connected now. This is called a internetwork. This is called a internetwork. Connection of two or more networks. Connection of two or more networks. Now, because they are connected, so we can able to communicate. So A1 here can able to communicate to this C1. Okay? This A1 now can able to communicate to this device to other networks. So communication between the networks, communication between these networks called a internetworking. What is internetworking? Communication between different networks. Internetworking. Okay. Okay. So we use a device called hub or switch to create a network. To create a simple network, you can use hub is a device or you can use switch device like this. I'm creating these networks using hub or I can use a switch also. Anything you can use it depends upon the size of the network and based on the requirement. You can use hub or a switch device. Okay. Hub or a switch device. Second, I am connecting these networks together using internetworking device. So it is internetworking. So to create internetwork and internetworking purpose, we need an internetworking device. That is called a router. The device here to connect between the different networks and make them communicate is internetworking device that is called a router. Okay. So this is total. Okay. Internetwork, network, networking, internetworking. Okay. Got it, guys? What is network? Okay. Hub and switches use it to create a network. So the router is internetworking device to make a communication between different networks. Network can be a physical network or logical network. Here what we have drawn is a physical network, means devices are physically connected. So then they are communicating each other, right? Whether network or internetwork it is. It's a physical network. What is a logical network? Logical networks based on the logical address. Here we use IP address is a logical address. So based on the IP address configuration, we create a logical network. For example, in one network, in a simple single network, okay, you have 100 devices. Just you are connected 100 devices. It does not mean they will all communicate each other. So you have to configure logical address in it. Means IP address, either IPv4 or IPv6, you should configure. Either IPv4 or IPv6, you should configure it. So based on the IP address, logic, they will communicate each other. Again, In case you have 100 devices, in the out of 100, only specific 20 devices want to communicate each other. You want to make the communication between only 20 devices only. And other 80 devices will communicate separately in the same physical network. How it is possible? Same thing, IP address configuration only. Okay, simple part. The next step. So this is about your network, networking, internetworking, router, switches, physical network, logical network part. About what is why you need a network, what is the use of network, what is meant by communication. Yeah. Actually, yeah, I will give you normally we are giving full explanation about this physical topologies, types of network. But what you do, guys, you will search about these physical topologies, okay? How it is connected and types of networks also. But just we'll give a points only, just a point wise. So it will reduce the time limit. Certain things compulsory I have to explain. Definitely I will explain devices and IP addresses and everything. This is most of you know it. If in case you don't find any relevant information anyway, don't use ChatGPT, use Google, any website, or maybe YouTube also. You can use it to find what is this physical topologies and what is this landman kind of stuff also. I will also share certain related videos so that from there you can also get it. Okay. Physical topologies. So what is physical topology? The way of devices connected. You can connect the devices different ways. What I drawn, that is a star topology. So this is a device, hub or a switch. I connected a devices to hub or a switch device. Then I created a star topology. Okay. But not only star wise, so different ways of connecting devices. Like a bus topology, ring topology, mesh topology, star, and hybrid topologies. Hub and spoke, spine and leaf, tree topology, point to point and multi-point, other kind of topologies also there. Simple point, bus topology, if you take a devices and connected to a single backbone cable, and the devices will communicate it through this backbone cable, bus topology. And also important is, guys, take your a paper, not now, later. So when you are reading about this networking in a time, like in afternoon, after the sessions completed, take half an hour and practice how to draw the bus topology. In case if you do not know or know, and either way, so try once at least how to draw this bus topology, ring topology, mesh topology, star topology also. Just in case, just 1% of possibility of they may ask you to draw this topology and show us whether you are really learn or not, like that purpose. Okay, in interview purpose. Again, bus topology, the devices are connected to a single backbone cable, so they are all communicating through this backbone cable only. Okay, so it is easy to configure, difficult to troubleshoot. The backbone cable here generally use coaxial cable. This coaxial cable support up to 800 meters. After 800 meters, you can use repeaters. So then you can connect multiple devices to this cable. Okay. So that is bus topology. Ring topology. A device is connected to another device, other device is connected to another device. Finally, the last device is connected to the first device. That like you have created a closed loop. Okay. Here it is. A send a packet to B, B send a packet to C, C will send to D. D will send to E, E will send to A. It's either clockwise or anti-clockwise, it will communicate. It is also easy to configure, but very difficult to troubleshoot. And one way or other way communication only works. For example, if C device is down, A to B communication is there. D to B communication is also there, but B to D communication is not there. That's a ring topology part. Mesh topology. Every device is connected to all other devices. Here it is. If one of the devices is down, only that device is not working. If one connectivity is down, only that devices won't communicate each other. Remaining devices will communicate each other. There is a mesh also redundant. Means one way or other way, devices will communicate. It's not depends upon one device or one cable kind of stuff. Okay. Next. Of course, mesh topology is a complex topology. Only one point I want to say, that is about mesh topology, where the people will be confused in the mesh topology. What is this? Which topology it is? Anyone?
Star.
Topology.
Very good. In our colleges or in institutions, to draw easy way, they draw like this. This is not a star topology, guys. This is a mesh topology. Because of you putting a Christmas star, people think it is a star topology. If you look at now, every device is connected to all other devices. If you take a 5 devices, we can easily simply draw. If you take a 10 devices, we can't draw with the star. Okay, it's not a star topology, it is mesh topology.
Okay, sir.
Okay. So commonly we thought, because there is a star topology, automatically when you see a star, we thought it is star topology. The original star topology is you have a centralized device called a hub or a switch. You can use hub device or switch device, a centralized device. All other devices, all the devices are connected to this hub or a switch. Okay. So this is an actual star topology. So the concept of star is here. It's a star shining. Okay. It's a star shines, right? Like sun. Sun is a star. Okay. So that's why it is called a star topology. Okay. So this star topology we are all using. In the star topology, additionally, we are using extra device to connect devices. And devices will communicate each other through this hub array switch device only. You want to communicate between the devices will communicating through this hub array switch device only. It is very easy to configure, easy to troubleshoot, easy to scale also. It means in your network, you got a more number of devices. These hubs and switches has a limited port numbers on. For example, you take a standard switch, it contains only 24 port. 24 ports means 24 devices you can able to connect it. But you have a 50, 100, 200 devices are there. How you will all connect, how you will connect everything into single network? Simply we'll take multiple switches. We connect the devices to these switches and we connect a switch to another switch like that. We connect one switch to another switch like that. Then we created a one single big LAN network. Okay, all these devices now are in the same physical network or single segmented network or single physical network. Okay, single large network it is. See, this is called a extended star. That's why it is scalable. Means we are ability to increase the size of the topology. we can ability to increase. That is called scalability. But it's not redundant. Why not redundant? Of course, if one of the device is down, that device won't be communicated. If one line, one network, one connection is down, only that device won't be communicated. But centralized device is down, means the device is connected to the centralized device, cannot communicate each other. Okay. But it is easy to troubleshoot because these hubs and switches having LED indication. So by any device facing not connected, we can look at the switch or hub. By the LED indication, we can see that cable is down or system is down or entire switch is down. We can easily understand, identify where is an issue. So then we can able to resolve it. In troubleshooting, what is the first thing? Identify the issues and where is that issue is occurring. If you identify those things, we can easily find the solution. So these are the main topologies: bus, ring, mesh, star, and extended star topologies. Point to point. If you connect one device to another device, you simply can say a point to point communication. In another way, it is you have a head office, branch office. Head office network is connected to branch office through a WAN connectivity. That is also a point-to-point connection. A router connection is also point-to-point based connection. And you have a head office and multiple branch office, point-to multi-point connection. Another example of point-to multi-point connection is satellite. One satellite is connected to multiple transponder stations in earth stations. One satellite is connected, sending a signals, right? You are getting dish TV in your home, dish antenna from a satellite. But it is not two-way communication, so it's a kind of single-way communication. Tree topologies. So actually, when I studied about a networking kind of stuff, that there is no tree, hub, spoke, and spine and leaf is not there. But tree topologies, people recently asking. So this is a tree. See, the middle one is a backbone cable. Think like it is a kind of fiber optical cable, a backbone cable. The different topologies are connected to this backbone cable and communicate. Nowadays, we are using this fiber optical based internet connection. Your home, one network, others home, another network. But we are all connected to a single ISP through it's a backbone cable. Hub and spoke is similar to your star topology. Hub and spoke is not different from star topology. But spine and leaf is a kind of tree or a multi topology. Actually, this spine and leaf is a combination of mesh and star topology. It is called full mesh topology, a hybrid topology. Spine and leaf is a hybrid topology. It's called full mesh topology, means mesh and star topology. In mesh, redundancy is there. In mesh, there is a redundancy, means if this device is down, only that device cannot communicate. Remaining devices will communicate each other. If this cable is broken, only these two devices cannot communicate each other. But remaining devices will communicate. That's a redundancy. And no centralized device here. But we are adding a centralized device to mesh is a full mesh topology. These full mesh topologies are hub and spoke topologies we use mainly in core networking, SAN storage. Yes, we use this kind of stuff. Like you have a network, your network is connected, right? This is your like in your network. These switches are maybe a router wise. You can see this is a different networks are connected here individually. And these are all connected to a central router or a switch kind of stuff. In case if this is down, all these connections can be failure, right? So what these people do it, a kind of mesh redundancy type. They made a secondary connection from here. So now if this is done through this, it can able to communicate. Okay. Okay, see it is. It's a kind of mesh and star. It's called a spine and leaf topologies. Usually used in SAN storage networks and core networking places. If one device is down, that device is connected to a multiple networks are connected, multiple devices or multiple networks are connected. Those are all faced a failure. So instead of that one, if one is down, no problem, we have another device to connect and communicate. So that is the point here. This is about your physical topologies. Okay, guys, understand anything? Bus, ring, mesh, star, hybrids like a spine and leaf, street topologies, star, extended star topologies. This is again a small topic, but just as I said, guys, I don't deep dive, just you will search. But I will give you basics, guarantee. Okay. Different types of network. These types of networks based on the geographical range or size wise on. Okay. Based on the geographical range or size wise on. LAN, local area network. Campus area network, CAN, metropolitan area network, MAN, WAN, wide area network. Plus, there is a lot of other area networks also there. But out of that one, I like the two. So then I put the two area networks. One is PAN, personal area network. Another one is HAN, home area network. This LAN is, the range is between a single room to entire building. So geographical range and geographical size based only we are talking, not based on the connectivity. Okay. So here it is a size wise you can take it. For example, in a room, you have a multiple devices and you connected and you created a LAN, a single network you are created. But entire floor is, your organization is completely one floor, entire your organization. All are connected. All devices are connected. Entire floor, you have 100 devices. 100 devices, you are connected and you created a single network that is a LAN. Maybe your organization is in the multiple floors. So then also it is a single LAN. Multiple floors you are connected. So that maximum size of a single LAN is your building. It does not mean building is small building or big building. Okay. It's an entire building, one LAN. Up to that ranges you can find. You go to the campuses, college campus, university campus, or maybe organizations. Organizations campus is also there. Different buildings for different process and organization buildings are there. Each building think like a one single LAN and you combine all the LANs within the campus. And within the campus, people can able to communicate each other between different building networks using CAN. Means your CAN size is entire campus. Campus area network. Campus area network. Okay. Within the organization, within the campus. Metropolitan area network. You take a city. A city or a metropolitan city. In a city, we have a different things are there. People are there. People, buildings, houses, right? Different departments also there, police department, health department, fire department, water department, okay, judiciary department, like that. So there is a lot of departments also. So you have a data information servers. We are connected everything as a single large network within the city. In the city, people can able to communicate each other. People can able to connect to each other and do all different kind of communication within the city only. For example, for my home, I need a water connectivity. So I no need to go to the water department. That's department I no need to go. Simply, I'll go log into their website and applied for the water request, water connectivity request. So those people get that information, okay, the notifications, information. They will follow up my request and provide a water connectivity. Simple example. I want to pay the current bill, okay, electricity bill. So simply I will log into the electricity department server. So log in with my ID. So check what how much bill it is, then pay the bill. That's it. So simple. We are making communication between the why we need a man. So within the city, people are able to communicate. They share information, data, transaction kind of stuff. They can able to do it. Next, finally, wide area network. So this wide area network, so organizations are located in different places. For example, 70s, New Jersey office, 70s, Hyderabad office. Okay. In the New Jersey office, we have an infrastructure like server storages, right? Database servers, file servers, web server, like I have a certain server. Here also we have a different types of servers. And people are working in both offices. These people want to communicate each other. They can want to share information, data, resources like that. This person has to access this database server. How do they can do it? Both are geographically separated. So the WAN connectivity. Okay, WAN. What is this? So they are communicating through WAN. Wide area network. Wide area network is connecting globally. Global network it is. Okay. So in different geographical locations, we can able to connect and communicate and share our information, data, and resources. PAN, HAN. Guess these are the standard types of network. LAN, CAN, MAN. Standard networks. So these are additional things. So many are there, but I like these two. That's why I'm putting. Even nowadays, people are also asking in internet. Personal area network. I have my own area network is there. What is that? My devices, my mobile phone, my smartwatch, my smart clothes, my smart shoes, like my devices I connected through using mobile, Wi-Fi hotspot kind of stuff. I connected and make them communicate and sharing information. Example, just you walk for certain steps, your smartwatch, it detect that number of steps you made it. It share that information to your mobile phone application, smartwatch application. So you will get to know so how many steps you made. Or you got a call to your mobile and you can able to get to see from your smartwatch, even you can attend the calls through your smartwatch also. So we are connecting the devices, personal devices, and make them sharing information, data, and resources. Home area network. In our home automation kind of stuff. Okay. Your smart TVs, smart LEDs, smart plugs, smart ACs, like a smart home appliances, refrigerators, like that. Okay, smart home appliances. We can connect them through using Wi-Fi hotspot. We can connect it, make them communicate, can control them using voice or through mobile application also we can do it. We can attach this Alexa, Echo Dot or Google Home Next, so then make them communicate each other. Okay. Some people added this SAN, but SAN is actually not a network, guys. It is a storage solution mainly used in the enterprise wise only, not in your home or normal offices. Okay. SAN is a storage related network. It's not a network, it's a storage solution. Storage devices, storage arrays, storage servers are connected and maintain the storage to store the data inside. Okay. That's the part. Again, LAN, local network it is, so your kind of private. CAN within the campus, MAN within the city, we can able to communicate. WAN, it's a global network, private to private, and WAN over the public is called our internet. Internet means we are connecting through WAN only, but it's a public network we are connecting through WAN. That is what we are saying is internet. Okay. This is SOHO. Later we'll see this SOHO. What is intranet internet? Also we're going to see. But up to here, understand, guys, different types of network, different topologies, and different types of networks. Names at least. What are the different types of network? LAN, CAN, MAN, WAN. Local area network, campus area network, metropolitan area network, wide area network. LAN, local area network, within the range, you can say within the room to entire building is a range, is LAN. CAN, within the campus, within the campus, people able to communicate each other. MAN networks means within the city, people can able to communicate. Like entire city are connected, let them communicate. That's it all, not outside of the city. Now we are using all LAN or WAN only. Of course, CAN is also implemented in the campuses wise. In the campus only CAN is implemented. In certain metropolitan cities, they implemented MAN type of network for metropolitan purpose. Okay. Wide area network is a global network. It is. In the global, any location, any geographical location to any geographical, we can able to communicate by through WAN connectivities. Okay, guys, you have to tell me whether you got it. Okay, not okay. Because you say, then I can give you a break, whether you understand or not understand. If you say, I can give you the break.
Yes, sir.
Hmm.